So today's lesson is our M16. We're going to talk about greatest common factor today, and this is something you guys learned a while ago. So let's just jump right in. So the greatest common factor, GCF, of a set of numbers is the largest factor that all numbers share. So let's put largest factor in this blank. Wow. For example, 12, 20, and 24 have two common factors, 2 and 4. The largest is 4, so we say the GCF of 12, 20, and 24 is 4. GCF is often used to find common denominators, okay? So also, what is the GCF of 24, 60, and 144? So yes, they're all divisible by 2. They're all divisible by 4. So you keep going bigger and bigger. Well, what I know is that all 3 of these are divisible by 12. This is divisible by 12, that would be 2. This is divisible by 12, that would be 5. And this is divisible by 12, this would be 12. So the GCF is 12. And so another way to do this, y'all, is to start dividing it by numbers and see what comes of it. You know, so if we had divided 24 by 12, then or by 2, and then we would have seen that it was 12. And you should be able to see that all of those are factors of 12, okay? So we're going to do a couple of examples here today. So it says examples 1A through F. We're going to factor out the GCF of the polynomials. So on this first one, looks to me again like this is a factor of 12, because 12 times 4 is 48. So 12, so that would be 4x squared minus 1. Remember, when you factor out, you're going to divide the number by the GCF, okay? So with B, again, I'm thinking, so yes, they're both divisible. I could divide 54 by 4. I don't think it'll be divisible by 4. And look, again, remember, we're talking about whole numbers here. And then 3, maybe 3, but I don't think so. So you can just keep dividing the number by whatever you think the GCF is. Obviously, they're not going to be divisible by 5, but if I divide them both by 6, that's going to give me 9x squared minus 4. All right, so let's see if you guys can do C. So this one's actually pretty easy because the only thing both of them are divisible by is 2. So we divide them by 2, and that gives me 49x squared, and this is minus 36. Now, next week, we're going to talk about the sum and difference of perfect squares, and all 3 of those are the difference of perfect squares, because 4 and 1 are perfect square, 9 and 4 are perfect square, and 49 and 36 are a perfect square. So we're going to actually jump into that next week, okay? So this was kind of like a precursor to that. All right, now let's look at D. We've got 56, 28, and 70. So what do y'all think? Yeah, they all look like they're divisible by 2. Not 4. Not 5. 6, 7. The last 2 are 8, 9, no. 10, obviously no. 11, 12, no. 13, 14, that's my number right there, 14. So when I divide 56 by 4, I get 4x squared, or 14, sorry. When I divide 56 by 14, I get 4x squared. When I divide 28, I get 2x. When I divide 70, I get 5. So again, that's me factoring out my GCF. Now let's look at E. So I already know that 36 and 18 are divisible by 18. So the big question is 54 divisible by 18? So, and it is. So I divide 54 by 18, I get 3. So my GCF here is 18. So this is going to be 2x squared minus 1, or minus x. Let's just say minus x. and then slash 3. Okay, now this last problem, mine looks a little bit different than y'all, so I'm going to go ahead and add the y squared and the y to the third and the y to the fifth. Okay, so now again, we're going to look at our first number, 24, 16, and 64. So 4 would go into all of them, 2 would go into all of them, 4 would go into all of them, but I think 8 also goes into all of them. Now, what else also goes into all of them is a y squared, right? So this one was a y squared, y'all, in case you can't see it. My writing's not so clear, so let me see if I can make this a little clearer, y'all. That one looks like a 3, the last one looks like a 5, but this is a y squared and this is a y cubed, okay, on y'all's paper. So we can actually factor out of this one an 8y squared because there's a y squared in all of those problems, okay? So this is going to be 3x squared. We got rid of the y squared plus 2. Again, we got 1y left if we take out 2, so that's going to be xy. And then down here is going to be plus 8. And again, if we take out the 2, it's going to be a 3. So this is going to be y to the third. Okay, remember how that works? Hopefully so. So basically, when we divide something out, we subtract the exponents, okay? All right, so now let me go ahead and fix this number 6 because it's not like what you guys have on your paper right now either. So let me go ahead and fix it. The original was x squared y to the fifth. And then this one is x y to the third. And then this one is y to the third as well. Okay, so if I start working through the numbers here, for example, let's just say I think it's divisible by 4, okay? So if I divide them both by 4, what I'm going to get is 24 here. And when I divide 216 by 4, I get 54. Well, these are still divisible by, let's see. Both of those are divisible by 3, if I'm not mistaken, y'all. So if I divide this by 3 and this by 3, I get 8 and 18. Which are still divisible by 2. So I'm just showing you guys how to work through this process. So this would be 4 and 9. So let's just go ahead and multiply 2 times 3 times 4. 2 times 3 times 4 is 24. So let's try 24. So I'm just showing y'all a process here for doing this, okay? So if we divide both these numbers by 24, 96 divided by 24 is 4. So that would be, let's just put 24 out here. So this would be 4x squared. And if we divide 216 by 24, we get 9. And again, there's that difference of squares, y'all. All right, so this next one, I'm going to try 3. So if I divide them both by 3, I get 25x squared. And when I divide 243 by 3, I get 81. And again, those are the difference of 2 squares. This next one, yeah, well, I'm going to divide this by 5, y'all, because it looks like both of them would be divisible by 5. This is 25x squared minus 64, okay? So number 4, 35 and 49 are divisible by 7. Is 91 divisible by 7? Yes, it's 13. So we're going to divide this. So this is going to be 5x squared plus 7x plus 13. Then number 5. Again, if you're looking at this and you're like, wow, I don't even know where to start. So on a problem like this, I know that 65 is divisible by 5, right? So divide the 65 by 5 and you get 13. Well, then let's try 13 with all the numbers, okay? So if I divide 65 by 13, I get 5. If I divide 39 by 13, I get, negative 39 by 13, I get negative 3. And if I divide 182 by 13, I get 14. So 13 is our GCF, okay? So there's a couple different ways to kind of approach this. If you know something is divisible by a number, then I would start there and see if, once you've divided it by that, see if it works with all the other numbers, okay? So this last one, I'm looking at 99, 143, and 165. So I would probably divide all these numbers by 9 first. You could start with 3, but I would divide by 9 just to try, okay? Well, all of them are not divisible by 9. Well, what's the other factor of 99 and 9? It would be 11, right? So let's divide them all by 11. So they are all divisible by 11. Now, I want you to also notice we got a y in every one of them. So we're going to take our biggest factor of y, which is y to the third, and we're going to factor it out. So this is going to be 11, and this is going to be 9x squared. And when we take out the y to the third, this is going to become the second, right? So this is going to be y to the second. And then plus, when we divide 143 by 11, we get 13. And the y to the third goes away here, so we're just left with the x. And then when we divide 165 by 13, we get 15. And again, the y to the third goes away because we factored it out. And it should be out here, y'all. Sorry, I didn't write it out here, but there it is. It's on the outside, okay? So there they all are.